The last video for the juniors that I taught 25, 26. Here she is. Given the cosecant of theta is x minus 1 over 2, find the tangent of theta. So it's kind of a big deal that you draw the way I taught you to draw. Otherwise, we get different answers. Theta in the corner, we draw like we're on the imaginary xy axis, okay? The cosecant ratio, that's Santa's favorite ratio. Oh, hypotenuse over opposite. Now, the goal here is to find tangent, right? Which means you need opposite and adjacent. You ain't got it. So a squared plus 2 squared must equal x minus 1 quantity squared. And then we're just going to do some math. We're going to write this thing twice. This is 4, by the way. And let's see here. If we FOIL here or box, whatever we do, we'll have x squared minus 2x plus 1. We're going to take that 4, we're going to subtract it. So a squared is x squared minus 2x minus 3. And then the opposite of squaring would be square rooting. And just making sure I did everything right. All right, cool. I'm good with what I wrote. Now I can find the tangent ratio. And we're not really going to clean it up any. We're just going to leave it as opposite, which is a 2, over this square root of x squared minus 2x minus 3. And there's number 1. All right, what do we have here? 3, evaluate 6 trigs for theta. Drawings are required. Use the reference angle theta prime concept. So, let's do this 27 pi over 3. Well, actually, no. That needs to be changed. Edit the homework and make that a 28. I'm going to pause real quick while I do that. All right, so back, I had to modify that real quick. 28 pi over 3. So the reason I did that was because you couldn't do reference angles 27 pi over 3. So let's go ahead and make this thing a degree. Actually, well, yeah, we'll make it a degree first because that's how most people think. Remember, pi is worth 180. And let's see here. So we got 28. Maybe if the TI-84 turns on, there she goes. We got 28. 180s over 3s. If you don't know that's 60, TI-84 don't judge, now does it? And we're going to use also the concept of coterminality. We're going to take away 360 until we can't take away 360 anymore. I can do it 2 more times after this. All right, so we're going to talk about a 240-degree angle. It's coterminal with 240 degrees. So 240 degrees is going to rotate you to about right, what, there? Okay, that would be theta, all right? We're going to use theta prime, and we're going to go ahead and triangle out. Now, the reference angle, which measures 60 degrees, would lie right here. I know it's 60 because 180 plus 60 is 240 degrees of rotation. Think about the 30, 60, 90 patterns that you've been asked to memorize. Not that you did, but you've been asked. Opposite of 60 degrees is root 3. Opposite of 30 degrees is 1. Hypotenuse is 2. So opposite of 60 is a root 3. Adjacent is a 1. Hypotenuse is 2. Now, the reason those are both negative is because one of them's running left and one of them's going down. Like, that's it. Anywho, now I can do my 6 trig functions. So the sine of theta, of course, this is also a unit circle concept. Opposite over hypotenuse, negative root 3 over 2. Maybe you can establish that connection in your head. Cosine of theta, adjacent over hypotenuse, negative 1/2. Tangent of theta, opposite over adjacent. That's negative root 3 over negative 1. And the negatives cancel, and we just write as root 3. Let's see, cosecant of theta, she is the hoe, hypotenuse over opposite. That's 2 over negative root 3. We clean that up by multiplying numerator and denominator by root 3. And we get negative 2 root 3, sitting pretty over 3, because root 3 times root 3 is 3. Then we have secant, it's the funny guy. Hypotenuse over adjacent, that's going to be 2 over -1, which we write as -2. And then we have cotangent, not pronounced cot, cotangent. AO, adjacent over opposite. That's a -1 over -√3. We multiply both the z numerator and the z denominator by √3. The negatives cancel as well. A √3 times √3 is 3. Easy peasy lemon squeezy. I have the answer here for you. You just have to show all the work. 5. Evaluate the expression in both radians and degrees. Draw to find all angles measured between 0 and 360 degrees. So we have the cosecant of 2 over √3. Sorry, we have arc cosecant. So we're supposed to find the angle whose sine cosecant ratio is 2 over √3. Now, what I notice is this is positive. So think about ASTC. I can exist here and here because this is sine and cosecant, and this is all, and that's positive. So I'm going to draw a triangle in both quadrant 1 and in quadrant 2. I'm going to put a theta here, and I'll call this one theta 2. So I have theta 1 and theta 2 because there's two answers to this thing. The cosecant ratio is the whole, hypotenuse over opposite. So I have a 2 and I have a √3, and I have a 2 and I have a √3. And this is supposed to be enough for you to figure out what's going on here. Of course, this would be -1 because it runs left, and so be +1. The idea is that this is a 60-degree angle. And this guy is also a 60-degree angle, at least its reference is. Now think about rotation. To get from the initial side to the terminal side, you rotate 60 degrees. All right? To get from the initial side to the terminal side here, you rotate everything but 60 of a straight angle, and 180 minus 60 is 120 degrees. Easy peasy lemon squeezy, right? I think it is. All right, now we're supposed to work with pi rads. Probably do 2 of them for you. Let's look at 10. This guy is negative, and this guy is bigger than 0, which means it's positive. So let's talk about ASTC. Sine is negative here and here because sine is y. That's where y is negative. The tangent ratio is positive here. This is where my triangle is. My triangle exists in quadrant 3 because both situations were true. So again, this is actually theta prime. It's not theta. Theta is all of this. This is theta. Anyways, sine is opposite over hypotenuse. Hey, it's another one of these. Opposite's -√3, hypotenuse is 2, 1. The reference angle measures 60 degrees. That's what it measures. Now, to get from the initial side of the angle to the terminal side of the angle, you rotate the semicircle of 180 plus 60, 240 degrees. Now, I want my answers as pi rads, okay? Say you forget the formula. You multiply by pi over 180. All right, that's what you do. You just don't put the pi key in the calculator because if you forgot the formula, you probably are that kid who's going to push buttons on the calculator, to be quite honest with you. And then you hit math enter, enter, and you get 4 over 3. Don't forget about pi, which is exactly what it is because you were tasked with memorizing that anyways on the unit circle. I shall do number 9 for you, the secant ratio. Think about ASTC. All trig ratios positive, cosine and secant are positive. This guy has 2 answers. Now, everything in the world exists over a 1. We have a triangle in both quadrants 1 and 4. And the secant ratio is the funny guy. The hypotenuse is actually √2. And the adjacent is a 1. They share this side, and it's 1. And this has to be 1 as well. Because that's how it works. Because it's a special pattern. This is a 45, 45, 90. Both of them are. And the first one's easy because this is the actual rotation it takes to create that first triangle. So one of my thetas is 45 degrees. The other one, and a lot of this just hinges on, like, did you actually comprehend the unit circle or not? I'm all of a circle but 360, and it's one of the numbers you memorize. I am 315 degrees. Of course, these are supposed to be in pi rads, right? So 45 degrees is one that hopefully 99% of my student body has memorized as pi over 4. 315 is also on your circle quizzes, 7 pi over 4. You're welcome. I did 2 of them. All right, using your knowledge of, it should say of ASTC, and your calculator, find theta on the interval from 0 to 2 pi unless restrictions are given. And draw it. Remember, the calculator only gives a half answer. Work in degrees, then convert to radians. So I have no idea, and we're going to work in degrees and then convert to radians. I have no idea what angle has a cosine ratio of negative 5600ths, but I do know that this is negative. So the answer has to be either here or here, because sine and cosecant are positive, everything else is negative. Tangent and cotangent are positive, everything else is negative. The calculator is only going to tell me this one. All right, make sure I'm in degree mode. Dun, dun, dun. Arc cosine of negative 0.56. And the reason I did arc cosine here is because to get theta, that's what I do. It's about 124.06 degrees. So the actual angle looks like this, 124.06 degrees. Now, what matters, and that is one of the answers. It is. That's one of the answers. To get the other answer, you have to understand that reference angles are congruent. So a straight angle has 180 degrees. So if I take my previous answer away from 180, I have a reference angle of 55.94. Which means there's 55.94 here. All right, now positive rotation to the same location would be the semicircle of 180 plus that. And I get 235.94 degrees. Now, the fun part, to convert an angle from a degree into a pi rad, or just a radian in general, we multiply it by pi over 180. Too many zeros there, right? And that one's about 4.12 rad. All right, the one above it, being a little extra with the parentheses here, is about 2.17 rad. All right, in an inverse, I really don't want to do a whole lot of these because they're not that hard. Let's just do 16. Step 1, swap x and y. Get the h out. And this would be my variable. Okay, so it's going to become x. Sorry, it's going to become y. All right, resolve for y. So first thing I'm going to do is I'm going to divide by 4. Let me leave some room here, because the next thing I'm going to have to do is going to be inverse tangent or arctangent. So put a tangent here with some space, 3y plus 4. The opposite of tangent would be arctangent, inverse tangent. It's actually supposed to be called arc. And they would annihilate each other. So the arctangent of x over 4 is now equal to 3y plus 4. We're going to subtract 4. The arctangent of x over 4 minus 4 is 3y. And the last move is simply to divide by 3. And that, boys and girls, is the inverse. Now, there's actually a little bit more to this. There's supposed to be a restriction and stuff, but it's okay. You're just in algebra 2. And that was the last homework video for the juniors who had me in 25, 26. We are almost done. And you don't have to see me again unless you want to. Nice.